Hello, how's it going? So at this point we have a ray tracer. We can run this and it traces rays. We have planes, we have circles and everything. This is nice. Now let's make it a little bit more involved. We're going to get some reflections in this session. We're going to change a few things and it's just going to be in the shader code. So let's jump through step by step. I'm pretty happy with the spheres. The camera is nice, the ray is nice. Plane, nothing needs to change there. Let's change the render state. So we're going to track the T parameter where we hit something, the color that we pick up at a surface, whether we hit, as well as the position that we hit at, and the normal that we encounter at that surface. Okay, fair enough. So what we're going to do is we're going to make reflections, repeatedly shoot the ray out. Okay, so we shoot the ray once, it hits something, then we will do this in a loop. So we'll orient the ray based on the render state that we get from information from the point that we hit, then shoot it out. Okay. Input, output, that is fine. Scene data, yes, that is acceptable. Okay. Now what we've been doing so far is shooting the ray out and returning the color that it hits. But now instead of that, let's shoot the ray out and get a little snapshot of what it's hit. So we're going to return a render state and we'll make this a little more general. We will call this trace. Okay. Unpack sphere, that's fine. Yeah, this is all okay. Right, so for our main, yep, we are setting up our ray. Okay, now let's take the pixel and by default, let's make that white. Okay, now we will loop. So we'll go let's start this off at 1 for now. Okay, so I have this for now. We'll send it out, and if we don't hit anything, then just break, right? Because we don't want to be shooting into the sky and then try to reflect from the sky. That makes no sense. All right. So the next thing we'll do is we will unpack the color. So we'll take the pixel and color it according to the color that the render state hit. Okay, so we start out at white, and then if we hit a red thing, we'll get white times red, and red will be our output. Okay, awesome. The next thing we need to do is set up our ray so that it can shoot again. So we need to set the origin. Okay, so ray's coming in at some direction, it's hit a surface and we know what the surface normal is. So if we reflect around that, that will be the new ray direction. Okay, then we'll go ahead and we'll store that image. Okay, awesome. So now we just need to go in and attack these functions. Okay, we can get rid of that, right? We're not doing that anymore. Okay. So we've got render state, and instead of this, we're going to go set that there. Okay, good. So I'm going to do a little bit of magic here. And the little bit of magic that I'm going to do is I'm going to call this hit function, and this will return a new render state. Okay, and then I'm only going to update if that new render state hits something. So I'll say if new render state hit, then nearest hit. Okay, great. We're going to change this to that already, and we'll go all right, cool. And this is very much exactly the same. So we'll go, yep, look through all the planes and do the same thing. Okay, that's looking good. We don't need to worry about this, right? We're already tracking this. We'll just return the render state. So because of this selective update, this will return the latest render state which actually hit something out of all these cases, because it's possible that we might hit a sphere and then fail to hit a plane. We want to get the sphere that we hit and the closest one that we hit. Okay, now let's just double check these ones, because we are now also storing position and normal. So just check that we're setting that up. Okay, so what we've got is we'll go okay, we'll get the position, and then the other thing is we know the normal on a sphere is equal to its position relative to the origin, right? So we'll go render state normal. If we go render state position minus the center of the sphere, then this is a direction vector which points from the center of the sphere outward to the position. In other words, that's the normal, and we just need to normalize that. And everything else here is fine. Okay, good. Yep, just double checking. All right, so then we have this one here, and pretty much what do we have here? We have this test point, and really that's the position of the render state. So we'll go and sample the normal from the plane. We know that a plane has a fixed normal. So fingers crossed, let's give this a shot. Oh, interesting. Let's double check that. Ah, what an error to make. This should be capital S. At least it didn't take too long to find it this time. There we have it. Okay, cool. So we've got it basically. Now let's take the reflection amount up. Okay. Let's get rid of that. Let's go one reflection, so two traces. There we have it. We're doing one reflection. So, yeah. Seems to be that the spheres are reflecting the ground. The ground seems to be reflecting the spheres. Fair enough. Let's crank that number up. It's a little hard to see, but I think we are getting some reflection on the ground there. Okay, that's interesting. And see, now we're getting some reflections. It's randomized. It depends on the positions of things. Now we are starting to get some, this looks okay. We're starting to get some slightly strange effects because these spheres are overlapping. But yeah, there it is. There is some reflections. Yeah, hope you had fun. And I'll see you in the next one. Bye.